Howdy everybody in land. So I know I've been talking about the 4000 in the last few videos, the WeatherStar 4000. I decided I want to change things up a little bit, and because I need to recap this machine anyways, I figured why not just do a video about it. This is the IntelliStar, the original IntelliStar, otherwise known as the IntelliStar 1, IS1. This guy was a rather iconic machine as well, along with the 4000. This came out after the XL. The XL is kind of that weird machine in between that uses SGI hardware. But anyways, so this machine here was very iconic because not only did it have different graphics package experiences over the years, this machine also runs weather scan. Currently, as far as I'm aware. It's kind of a shame that they're kind of letting it die on the vine, but that's a topic for another time. So this is a PC. Just all it is. It's just a PC. Actually, no, I'm just kidding. It's not just a PC. Otherwise, I wouldn't be doing a video about it. But in its heart, it really is just a PC. You got your standard ATX power supply. The drive, there's supposed to be an aluminum cage in here that holds these drives, and I just picked this up recently. These are extremely rare machines. They're very difficult to find, and this thing was actually kind of pricey, a little more than I wanted to pay for it, but it is what it is. So I just picked this up recently in an auction, and this is how it was packed to ship it. It's the most absolute ridiculous thing I ever seen in the world. And how in the hell does someone lose a drive cage? How do you do that? How is it even possible? It's just missing. I mean, you got to go through all the effort to take that out because there's 4 screws in the front, and then lose it on top of that. Anyways, whatever. I digress. So this is just an ordinary PC. This is an ATX power supply. The fans are very loud in this machine. CD-ROM drive, and unfortunately I did not get the hard drive for this machine, so I don't have the software or anything that this machine originally came with. I mean, it has this proprietary drive caddy and takes a standard SATA hard drive, but we'll get to that in a second. Let's take this top cover off. Alright, some of this is dislodged because I was in the process of taking this machine apart before I decided to do a video, so don't mind that. So, yeah, it's just an ordinary PC. It's a Pentium 4 2.6 gigahertz machine. Nothing special. And as we all know, the Pentium 4 line was a very bad line, in my opinion, the net burst architecture. But the reason why I'm doing a video in here is because there's a lot of goodies in this machine I need to talk about. And especially this card right here. This is the heart of the machine, and it's very special to this machine. It was engineered and designed specifically for this machine, and it's a very complicated little card, but I'll talk about that in a second. So this machine has bad capacitors. All of these machines are known for having bad capacitors because you can probably see a popped tops on some of the caps in there, and the machine has trouble powering on. In some of these cases, I'll get a better picture when I get all these cards out. But so this machine has trouble powering on. Since this particular machine is still being used in the field, these have been retired domestically in 2015. So there are no domestic units running local forecasts in the field anymore today on the IntelliStar 1. It's all the 2 series and newer. But there's still weather scan units out there, and these machines aren't getting any younger. So they're all going to die off eventually. So eventually weather scan will start dying on the vine. It is what it is. Because none of these machines have had a hard life, and they're not getting any younger, and the caps are going bad on all these boards. Anyway, so I want to get down to the hardware. There's some special bits to this machine that make it a little bit different than your average PC. For example, there's this board back here. This is a Phoenix connector that's got GPIO on it for logic relays, as well as the analog audio input output is handled on this card, where the audio goes through this ribbon cable. That's why it's got twisted pair of wires in here is because it's differential balanced audio, and that plugs back here onto this special board. This is just your Radeon graphics card, and then we've got Ethernet cards and stuff like that in here. So I'm going to go ahead and start pulling some cards, and we'll talk about that. All right, let's start with the first card. This card right here. Let's save the first one, the best one for the first one. This is a very proprietary card. This is known as the Thunderstorm digital board. This card was designed by a company called Wind River Systems, which is actually the same company who invented and designed VxWorks, the real-time operating system. And as you can imagine, this card is running VxWorks. So what this card actually does, this card is a full-blown video encoder decoder module. Capture device as well as a playback device, and it does real-time MPEG decompression and compression on the fly. So to put that into perspective, what that actually means is, in the late 90s, if you wanted to watch a DVD on your computer, you had to have, if your computer was below a certain processor speed, you had to have a special board installed on your computer. It was called a DVD decoder board. And most of them would just have a ribbon cable, and it would plug into your graphics card's feature connector, things like that. That board was dedicated hardware to do real-time MPEG-2 decompression to be able to watch a movie, a DVD movie. And then eventually computers got fast enough to where you didn't have to do that anymore. The processor could do it all, entirely. But this is a 2.6 gigahertz single core chip that gets really friggin' hot because it's a Pentium 4 anyways. So this board here does real-time MPEG-2 decompression as well as MPEG-2 encoding simultaneously. This connector here is the ASI out, which is the MPEG-2 output. So this card can actually take an image. So this maps itself into two locations in memory, /dev/playback and /dev/video. So it maps itself as a video capture device. Think of like a Blackmagic card today, or a USB capture card. So it identifies itself to the operating system as a capture device as well as a video playback device. So it's an input-output device, and there's a control channel and all that. I don't want to get into all those details. But anyway, so this card can actually read out the frame buffer memory from the actual AGP graphics card. So when this machine was rendering presentations in real time, the lower display line or the local forecast information, whatever was going on, that was rendered on the graphics card just like any other graphics software would, using OpenGL. You could use a video game, for example, like Duke Nukem 3D, whatever, So it's all rendered in this video card. But this card is special in the fact that it works as a bus master, so it can actually read out the frame buffer memory from this card into the memory in here. So then what happens is there's an incoming video signal from the satellite feed, whether it's analog or digital. It can take in MPEG or SDI MPEG digital as well. It will decompress it in memory and actually overlay the graphics information from this card here, from the frame buffer, then recompress it back out as MPEG-2 over this ASI port. So this board does everything simultaneously. It's a very powerful card. So this card basically has a PowerPC 750, which I thought was a G4, but actually it's a G3. Think of an iMac G3 on a board. That's what you have right here, with a hardware MPEG codec. This chip here is responsible for doing real-time encoding, decoding of the MPEG-2 video. And then there's the memory, the SD RAM, for handling those operations. This is a DSP. This is responsible for handling all of the audio going in and out of the machine. The MPEG-2 audio is happening over here, as well as the analog audio. So what we have over here is a couple of Cirrus Logic codecs. These are responsible for converting the analog to digital from the RAIN assembly in the back, as well as digital back to analog for the RAIN assembly in the back, because the RAIN assembly plugs in right there. And they get mapped into these codecs. And these relays here act as pass-through, so if you shut the system off and you have analog input, it'll just route the analog input right back to the output through these relays when there's no power. Otherwise, this chip here handles all the audio real-time processing. Now, this FPGA, I don't know exactly what its intended function is, because the RAM is interfaced with this chip here, this Marvell chip. This is a PowerPC to PCI bridge. It also contains all the logic for handling the RAM and all that stuff. This is like a north bridge. Think of a north bridge and a south bridge setup. That's a north bridge. This might be acting as the south bridge to map in the MPEG codec, these guys, and the DSP over to the PowerPC CPU. So this is a nice little heat sink, and the fact that it can actually twist off, and it just comes off like that. Look at that nice Motorola Gordon 7410 MPC 7410. I thought this was a 750. I guess not. The 7410. I'm pretty sure this is a G4 CPU with the AltaVec core, and chances are they're probably taking advantage of the AltaVec functions to transport, the MPEG. So the frame buffer copy operations coming in and out of the graphics card is probably handled through this CPU, and it buffers into memory while this codec can do its work. But and then there's these two connectors here which go off to the analog board, which I'll show you that here in a second. So this board here does all of the special stuff that the IntelliStar 1 needs to operate properly. So your DC-DC converters are over here to generate your core voltages for all of these chips. Your FPGA, which is probably acting as the south bridge. This is the JTAG header for the FPGA. You got a Cyclone CPLD over here, or it's not, I don't know if that's a Cyclone. No, that's an Altera Max, my bad. The firmware, including the RTOS VxWorks, is stored in here. Standard SD RAM, nothing special. And then your PowerPC CPU. So, and then there's some factory bodges here on the back. Nothing too insane, but it seems like they made a couple of mistakes on this board. You can catch it a little bit down here. I'd hate to have been the technician that worked on this, because I bet that was fun. So, anyways, that is the Thunderstorm digital board, and this is the heart of the machine. So you've got a PowerPC G4, G3, G4 inside of another system that's a Pentium 4, and the two have to communicate with one another. Man, the engineering feat that it would take to pull that one off. This is nothing special. Standard off-the-shelf Mitsumi CD-ROM drive. IDE, nothing special. We'll move that out of the way, and not to get everything knocked over. And here's that special carriage, which is bent all to hell. And I don't even know what it is. So I don't even know if I can even get a caddy for this thing anymore. Which doesn't matter anyway, because I bought something better to go in its place. So for all intents and purposes, yeet, get rid of that. It doesn't matter anymore. So now comes the fun part. In order to get the analog board out, I have to get all these nuts out. Otherwise it's not going to come out. And oh, what a pain in the ass. So I might as well go ahead and take a quick video shot of the back here. So we have a modem on the far right over here. I'm assuming that's for communications back to TWC, so they knew if there was a system down or something like that. We have an Ethernet port here, as well as one on board. chances are the data came in on one, and again, internet networking communications back to TBC on the other. And here's the RAIN assembly, which is your GPIO. This is your audio as well as your standard logic switches. And the logic switches are actually controlled by this cable right here. They're using the parallel port as a GPIO controller for all these connections here, which for the time, that was actually not a bad idea. So we have the RAIN assembly there, which if I can get a better look in here, and it goes through that ribbon cable, we might be able to get a better look at the failing capacitors. Oh yeah, they're bad, they're shot, they gotta go. The other neat thing about this machine is this power supply. This power supply is just a standard ATX power supply, but it's special in the fact that I think it was custom designed for this machine, because I've never seen another one like it. And it's modular. You can actually remove this power supply, which I have to anyways, because you'll see in the next video I have to recap this machine to get it running again. But this power supply also has caps in it that dry out and go bad, and when you first plug these things in, they do not want to turn on. But once you warm them up, they'll turn on, they'll stay on, and they'll operate fine 24/7. So that's likely why the ones in the field haven't shown any problems yet. But the minute these go into cold shutdown and you go to turn them back on again, you're going to have all kinds of problems. It's just not going to work. Trust me on that. At least not when they get to this sad of shape anyways. Because again, these boards were made in the Plague era, and Intel motherboards were not all that great anyways. That's just a standard Intel board. Nothing special. 865 series chipset. So let's get this analog board out so we can go over it. So here we have the analog board. And as you can probably tell, the information that goes over to the Thunderstorm card is going to be in a digital format. It has to be. So these chips here are designed. This SAA 7115 is an NTSC to RGB to digital decoder. There's some other chips here. I'd have to look them up on the data sheets to know exactly what they are. But I'll get them in the frame, so if you guys want to look them up, you can. But this one is designed to convert the analog video, because this has an analog video out, or it might be analog video in. Well, actually, it's both. So, let's see. Yeah, local video in, which is likely composite, satellite SDI, satellite NTSC, and then NTSC out. So, this is standard composite video baseband output from the card. So not only do you have the ASI out from the Thunderstorm board, but you also get the NTSC out. You have the satellite NTSC input, which is standard composite, as well as an SDI. SDI is the digital input. So there's a difference between ASI and SDI. I don't know exactly what the differences are, but I know that ASI has an MPEG out. SDI, I don't know if that's MPEG or if that's just standard digital lossless input. I'm not entirely certain, but it might be MPEG, and that board has the MPEG codec for handling it anyways. But so this one looks like it's seen some better days. I wonder if this unit was used nearby an ocean. But that's your voltage regulator. It's a 3.3 volt regulator, because these ICs are 3.3 volt logic. PCB made in China. No surprise there. So the SAA is the NTSC decoder. These chips can actually handle S-video input and output, even though the pins aren't used. But there might be a way to modify the board to actually use S-video, which would give you a nice clean video signal. You could use SDI as well, but the cleanest video signal you're going to get out of this is the ASI, because that's the raw MPEG. So that card, we'll set that card aside because there's not a whole lot to it. And this card here, which I will pull out now, Maybe. I never did like AGP because of the painful experience with the connector in the rear. I need both of my hands. Anybody that knows anything about the Pentium 4 era probably recognizes this card. It's nothing special, just an ATI. I think it's an 8500. Pretty sure it's an 8500. ATI Rage Theater chip. Yeah, you know, that's a good question. It's not really marked on the card anywhere. And here's why I say this. The IS-1 came with two different versions. They had the 8500 and then they also had the 9200. Which, honestly, I don't know how they dealt with that, because the problem is the two cards are not going to render exactly the same. So let's say their development machine was running a 9200 and they started improving the software and the graphics environment to where they run perfect on the 9200. As soon as you get to an 8500 system, it's not going to run as well, or it's going to give you issues. And there have been known bugs and known cases of graphics issues and things like that in these machines, and I'm wondering if that was related to it. So nothing special here, just a AGP video card. And the AGP bus is actually required. The software that this machine runs will not work on a PCI Express architecture because of how the AGP works. So AGP in the BIOS, you have what's called AGP size, where you can set your 32 meg, 64 meg, 128 meg. Well, that is the amount of address space that allows the machine to map frame buffer to the external address bus. Let's refer back to the Thunderstorm digital board. The Thunderstorm digital board grabs its frame buffer information from the graphics card, and it does that through the AGP bus, where OpenGL will actually map 66 megs of memory from this card to the bus, so that the card can actually autonomously, take over the bus as a bus master and read it and blah, 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 blah. Nasty details I don't really need to get into. But, yeah, so this card here is just your standard, Actually, that's a funny symbol for a card, but that's the Ethernet card. I'm not sure which manufacturer that one is. So why don't we go ahead and pull this out. Sorry if I'm not going into super detail, because this is just an overview video. I'll probably do another video before and after recap and then fire up with this machine. Okay, Netgear. Netgear what? Ah, crap. TP83816. I haven't seen that chip in forever. Yeah, just a ordinary Netgear card. 2004. So, set that one aside. CMOS battery, I'm sure, is long since dead. And this is a modem, which, who uses a modem anymore these days? I sure don't. Some people might play with them with telephone line emulators, but I don't. I just don't do any of that. Let's figure out what it is. Oh, 3Com. Nothing special. Not a Win modem, of course. US Robotics. Probably a 56K. It'd have to be a 56K. Yeah, anyways. Set that aside. For the time, this machine has a gigabyte of RAM, which in 2002, 2003, when this machine came out, was quite a lot of RAM. That's like 32 gigs today, if you were to think about it in relations. But yeah, here we go. We got another popped cap. It's got to be changed. So the reality is this thing's going to have to be fully recapped. Oh, and there's my two little washers that came off when I took the analog board out. Take that off. Take that off. Obviously, I don't want to plug the board in with all this crap in here. And they were actually ahead of the time, because The drive, the hard drive was hooked up with the SATA cable, and in 2003 I was not running a SATA hard drive. I was still all IDE. I didn't get into SATA until about '05, so it's pretty ahead of the time. Don't know if I want to take this RAIN assembly off or not. There's nothing really interesting on this board. Like I said, it's just audio and GPIO mapping to the Thunderstorm and to the main board. But man, you can really see the bad capacitors in there. Holy crap. They are bad. There's actually capacitors in there that I need to change that I didn't order yet. I ordered most of them. They're in this box. But those ones that are in the yellow top, I've already serviced a couple of these machines, and the ones that were here on the other motherboards were polymer caps, so I didn't change them. This one doesn't have polymer caps. These have standard electrolytics. So I'm going to have to change every single one of them. Ugh. What a pain in the ass. And then to get this, here's another thing. The case design is terrible because the ATX connector's all the way up underneath this power supply here. So I have to pull this board or pull this module out. Then it will reveal the screws underneath, including the screws in the front, so I can move this whole cage assembly out of the way just to get to this plug. It's why couldn't they just move this power supply back here like a normal case? No, they had to put it up here. I guess for serviceability reasons. I don't know. You can't buy these power supplies anywhere anyways, so why they were thinking serviceability, I have no idea. But there's the model number of the power supply, APR 3510. There might be on eBay, I don't know. But it's not very common. So let's see what memory module's in here. I'm curious to make the model. I've seen a couple different ones so far. Value RAM. Yep, definitely OEM. ATL, yep, that's a TWC proprietary part number. Kind of like a IBM FRU field replaceable unit. It's kind of what it reminds me of. DDR 400, 512 megabyte stick. The other 512 megabyte stick is up underneath it, so since there's two, it's running in dual channel mode. But yeah, that's it. That's all I have on this one at the moment. I'm going to pull all of this out, and I'll probably make a part 2 to this. Pull all this out, and I'm going to start yanking all the caps and recapping it, and then we're going to fire it up, and hopefully we'll have some fun once we get it all fired up. But that is the IntelliStar 1 in a nutshell. Thank you for watching, and please feel free to leave a comment if you have one.